Hi, welcome back. In our previous lesson, we started with algebraic representation of present and future values. Today, we are moving on to part 2. So if we recap from our previous lesson, we saw that the future value of money invested in the present is represented by this formula here, where I is the annual interest rate, T is the total number of years that the money is invested, and M initial principal invested. Today, we'll be moving on to the present value. Unlike future value, if we now assume that someone offers a contract that promises to pay you $100 a year from now, if we assume no inflation, what is the maximum amount that you should be willing to pay today for this promise? So this concept is what we call the present value. The present value is the maximum amount of money you'll be willing to pay today for the right to receive a given amount of money at a specific date in the future. To find this amount, given the annual interest rate I, you must find the number that, when multiplied with 1 plus I, will be equal to the $100 that is promised in the future. So if we assume a 5% interest rate, then algebraically, the present value can be written as the maximum amount of money that you'll be willing to pay to get the $100 in future, multiplied by 1 plus the interest rate, being equal to the money you are promised in the future. So then the idea is, when you're determining the amount that you should pay for that promise in the future, you should also take into account the given interest rate. Given this formula here, we have our present value being equal to 100 divided by 1 plus 0.05, which is equal to $95.24. Hence, if you are promised $100 in 1 year time, given the annual interest rate of 5%, the maximum amount that you should be willing to pay today for that promise is $95.24. So in general, when the annual interest rate is high, then the present value of a promise to pay $M in T years' time is simply a present value being equal to $M divided by 1 plus I raised to the power T. So this bit here is the money that is promised in the future, and the T here is the number of years that that money has been promised to be given to you, and then I is the interest rate. So even in the absence of inflation, a dollar in the future is worth less than a dollar today and must be discounted by an amount that depends upon the interest rate and when the money is receivable. So for this reason, I is often referred to as discount rate used in the computation of the present value. Let's now consider a promise to pay $0 today, $1 1 year from now, $2 2 years from now, so on and so forth for some T number of years. How much would this deal be worth today? The simplest approach is to convert each year's amount to its present value and then add them up. So we know that the present value is equal to the amount you are promised now. This does not need to be discounted because it's in the current period. Then the money that you are promised a year from now. So this is discounted with the interest rate because it's a future amount. And then the money that you are promised in 2 years' time, so on and so forth, up to T number of years. This formula is usually the case when we assume that MO is not equal to M1, which is not equal to M2, which is not equal to any amount that you are promised up to MT. So how about if you are promised a fixed amount of money? In this case, MO is equal to M2 is equal to M3 being equal to some MT. And you are promised this fixed amount of money forever. This is an example of perpetuity, which is a stream of income that lasts forever. How much would that perpetual stream of income be worth today? If we assume that the perpetuity pays a fixed amount represented as $M annually, to find the present value, we only need to determine how much money would have been invested now in an annual interest rate I% to obtain this $M each year. So we know that to answer this question, we have to consider an amount that when multiplied by the interest rate will be equal to the amount that is promised. So what we'll be looking at is present value multiplied by the interest rate should be equal to this fixed amount that is promised forever. So rewriting this, we obtain the present value being equal to M, which is the money that is promised forever, divided by the annual interest rate. So for example, if we assume a 5% interest rate and an M being equal to 250 promised forever, then the perpetuity or the present value of this promise is going to be 250 divided by the interest rate, which is 0.05. This is equal to $5,000. So $5,000 is the present value of a perpetuity that pays 250 annually forever at a 5% interest rate. So the maximum amount you should pay today for this promise is $5,000. So this is all that we have on our lesson on algebraic representation of present and future values. In our next lesson, we'll be looking at some practice question on the intertemporal choice model. If you enjoyed today's lesson, consider subscribing. Thank you.